Hello and welcome to today's webinar. My name is Tyler Reed. I'm the Manufacturing Application Manager here at GoEngineer, and I'm pretty excited about today's topic. We're introducing a new machine from Stratasys, one that I've been looking forward to now for, honestly, probably a couple years. We've been hearing rumors about this machine, how it was going to be a little bit different, what it was going to offer, and the more I've learned about it over the last 6 to 8 weeks, I have just become so excited about it. So we're going to be talking about the Stratasys J55. I do have some parts off the machine that we're going to show here during the webinar. Here at GoEngineer Salt Lake City, our machine got delivered today. In fact, I just rolled it off the truck about 30, 40 minutes ago. So it's still crated up. I wanted to show you guys the machine in person. That's going to have to wait. But for now, I've got some cool parts for you. The topic is turning design into reality. And this is super fitting because this Stratasys J55 machine is uniquely positioned for designers, industrial designers, designers of products, designers of aesthetic models, people who have a very strong incentive to have accurate color, a variety of colors, small parts, created quickly, designed faster, that sort of thing. So let's jump into it. So if you are a designer, you're probably familiar with 3D rendering tools, something like SolidWorks Visualize. This is a big component of your everyday workflow, is taking 3D CAD models and turning them into something that visually communicates whatever it is that you need to share with prospective customers, stakeholders, decision makers. There's a lot to communicate when you have a product coming up. You need to communicate brand, for one. Something like Porter Cable here. I've bought enough of their tools, or I've seen enough of their tools to immediately recognize that gray and the red. That's part of their brand. And if they were to release products that were slightly off color or different color, they wouldn't have the benefit of carrying that brand with them that they've worked so hard to build. On the other hand, there's more than just color happening here, right? We are designing hand tools that are meant to be ergonomic, easy to use, fit well in your hand, well balanced as you use them, not too heavy, that sort of thing. There's a lot that you're trying to communicate with prototypes. And historically, we've always had to deal with separate prototypes that are both physical for things like form, fit, and function, and quote, prototypes for aesthetic reasons. And really, we would rely on rendering to do that. Another example here from SolidWorks Visualize is the wood grain in these headphones. Wood grain is, it's really elegant. It's conveying a certain message to a prospective buyer that these are high-end headphones. These are high-class wood products. And you communicate that the best you can with the tools that you have available. And historically, that's been rendered. But I think we all understand that when you are looking at a picture through a monitor, you're losing a lot of that communication, right? Your message is not delivered as clearly as possible. And in the past, we have had solutions for that, but the J55 brings those solutions to an entirely new market. On the topic of rendering, you very rarely see early photographs or renders of products like this. Typically, it's behind a black background or a white background, and it's the product alone. But in this case, you see that people are handling the parts. People are touching the parts. There's a tactile feedback there. There's better communication happening. The reason why you don't see high fidelity parts, like you see here, in hands very often is because it's expensive and cost prohibitive to create high fidelity parts early on in the design process, which is why we rely on rendering. But in this case, with parts that coming off the J55, we're able to create high fidelity CMF models very early on in the process, gather feedback from prospective users, other stakeholders, and design a product that is better suited and better matches and better meets your end goal as a designer. That's what this is all about, giving designers more options, reducing the design time and the design cost to create prototypes, accurate prototypes. So like I said, in the past, we have had solutions, and sort of the top of the line PolyJet system right now is the J850. The J850 is an enterprise level PolyJet machine that allows you to load up 7 different materials at a time and create very high fidelity, high quality parts. But it comes at a cost that is prohibitive for a lot of design firms, right? Design firms that employ 5 to 20 designers and are taking on, 5 to 15 projects a year. This might be cost prohibitive for them. Now, we had a solution for designers, and that was something like the F-Series machine. The F370 would give you thermoplastics that let you prototype fit and function, but not necessarily branding and aesthetics and color. So we're missing something. We have a gap in our portfolio, and that's what the J55 is targeting. So the J55 is sort of this compromise between high-end PolyJet functionality with the small footprint, office friendliness of the F-Series. So excited about this because we haven't had a PolyJet system in this price range for quite a while, and certainly not with the capabilities that this has. Being able to load up 5 different materials, including these color materials, and print photorealistic parts and do it all in a machine that could be here in my office with me. It's completely unique in the market, and I think it's something that's really going to speak to every designer's heart. So why this J55? As I've mentioned, communication is key in the design process. You have a lot of moving parts. You have people with different ideas. You have markets that you're trying to hit and markets that you're trying to understand. And communication, linking everything, is key to a successful design. That communication has to be concise, it has to be clear, and it has to be timely. And all 3 of those things are really tough to hit when you're dealing with subpar prototypes and you're lacking information. For that reason, the design cycle is sort of inefficient. It takes a lot longer than it needs to, and it is a lot more costly than it needs to be. In an ideal world, we could snap our fingers and we would have 1,000 prototypes in our hands, and we'd be able to pick and choose and put them in the hands of prospective users and have them tell us, what do they like about it? What do they not like about it? That's important to understand your market, but we can't snap our fingers. Manufacturing doesn't work that way. And realistically, when we're going through conventional manufacturing methods like CNC machining, pad printing, urethane casting, these sort of things, they take time. They take days into weeks into months to develop prototypes. And it really limits our options. If we have, say a prototype for a mouse, like I have here, you might go through the process of developing a prototype and you put it in someone's hand and they say, oh, I'd like it a little bit bigger. Well, how much bigger? Because you're going to have to take a guess. You want it 5% bigger, 10% bigger, 15% bigger? Each one of those are going to cost the same amount of time and money. Digital manufacturing through additive manufacturing changes that scenario. With digital manufacturing, you can simply go into the software, put a scale factor of 1.1, and now you have a 10% larger. You hit print, it prints out in a few hours, and you have a second iteration. It speeds up the process. And not only does it allow you to produce better parts and better designs, but it allows you to hit your market faster. And months turn into dollars when you hit the market months sooner. I touched on this before, but there's something to be said about the idea of manufacturing in a box, right? And that's what the J55 is. It's a small refrigerator-sized box that could fit in my office and would totally be odor-free, nearly sound-free. It's something like 53 decibels operating, safe to use, and it would be an awesome roommate to have. It's not going to be loud. It's not going to require any sort of special ventilation or sound isolation or anything like that. We roll it right into our office space. It works right next to us into the desk, and it becomes a coworker of ours. And lastly here, this is something that's been on everyone's mind for years, but especially over the last few months as we started to see disruptions in supply chain, with the COVID-related shutdowns, is protection of intellectual property and confidentiality. And something that we've all become keenly aware is that anytime we send a design out to a partner, manufacturing partner, there's risk of bleeding your intellectual property. And in some cases, you come out scot-free on the other side. And in other cases, it can be devastatingly costly to defend your rights, unfortunately. So something that really is tough to put a price on is the protection of your novel designs, right? And so bringing manufacturing in-house and keeping it in-house is a great way to hedge against that. Now, the prototyping process with the Stratasys J55 is a little bit different than what you might typically see. I'm going to jump over to a website I came across earlier this week. And this is John Lai's design. And he has an online portfolio, and I was really impressed with how he laid out his design process. And I was really impressed with the outcome. So I kind of want to just go through this product that he talks about. And he kind of lays out the workflow from going from a minimum viable product to a consumer product. And you see that minimum viable product gets the job done, but from an industrial design point of view and from a point of view of something that a buyer would be excited to purchase and show off and buy and share with their friends, the MVP is not that, but the product that he landed on is. And certainly that influenced the sell of the design. He showed this image of prototypes in the hands of a prospective user. And you can infer from those hands that a small device like this may be difficult for somebody to really use. And if you look closely at these prototypes, they're really well done, about as well done as you could hope for when you're working with cardstock and hot glue and dowels and things like that. They're not high fidelity models, and you're really hoping that the feedback that this woman provides him is accurate and usable. And it all relies on the accuracy of the prototype to the final product. How true is it? So these prototypes do happen, but how valuable are they, and how much time and effort and labor is going into creating these? That's a good question. He goes through after those prototypes and starts sketching some conceptual ideas. And then actually they do turn to 3D printing. I was super surprised to see this, pleasantly surprised to see that as I was scrolling down, I see what I can identify as polyjet parts. But I can tell that these came off older models just because of the color schemes here. And I think in this case, the color scheme matched up with what the vision was for the product, more or less. Not quite probably perfectly accurate, but that's not always the case. And you can see that these prototypes are numerous. There's tons of different iterations. That's important. And I'm certain that the feedback from these prototypes, as you can see in the woman's hands, you can rely on that. You can have confidence in that prototype and the information given back. But look how important it is to put these in her hands. She's going through the process of cleaning the tips, sterilizing the tips, placing the device back into the case, placing the case into her pocket or her purse, and going through the process of using it. You can't do this without accurate prototypes. Once you have the shape, then it all comes down to branding and communicating and conveying a certain emotion to the buyer. And that is really difficult to do without high fidelity models and impossible to do without having accurate high fidelity models. So these are all renders at this point. These are all renders. With the J55, you could be creating these parts that are true to color very rapidly. So I wanted to share that. That's sort of a more conventional kind of hybrid approach. There is some 3D printing here. With Stratasys, you're not working with cardstock and hot glue and whatnot. It's purely digital. You are going to be doing some sketching, and sometimes you might be doing that sketching digitally. Sometimes it's on paper. Then you're going to be designing in CAD and rendering. You're going to be rendering in something like SolidWorks Visualize or KeyShot. You're applying the colors, the textures onto the models. And then you're hitting print. You're laying it out on the build tray and you're hitting print. And you're doing that process, sketching, rendering, and printing every step of the way. You're doing it for concept models. Maybe at this point you're using a draft gray material, low cost, high speed material. And then you're going into the detailed models where maybe you're starting to integrate some of the hardware and the electronics and printing maybe a clear case so that you can see how those electronics package inside the product. And then you're also doing it on a final CMF model, color and material and finish model, where you're trying to identify what's the color scheme that we're after. What's the emotion that we're trying to go for? That's an important part of selling the product. Engineers don't always understand this, but I know that you designers do. You're communicating through your product, and you're doing that through the color scheme. So let's talk about the J55 specifically. With the J55, we have a color space of nearly 500,000 unique colors. We also offer Pantone validated colors. So if we are going into manufacturing and we are being technical about our colors, we can specify Pantone 410, and that's the color that we're going at. And we can prototype specifically in that color because the J55 system, as well as the rest of the J series systems, are all Pantone validated 3D printers. Within the current portfolio of materials, we do have clear materials. I have one here that I'm going to show you. These are great for simulating acrylic, simulating glass in your products. You can encase parts with a clear to give you a thin, clear surface to polish, and really have a lot of control over the visuals of the part and also the finish of the part. And we also have really vivid translucent colors as well. Our core colors are cyan, magenta, and yellow. They're all very vivid, translucent materials. And when mixed with opaque materials like black and white, we can get solid colors, but on their own, they're translucent. So that allows us to have a lot of breadth in what we can produce. Not only are we hitting Pantone different colors, we're also targeting transparency. So I can say, I want this CMY value or RGB value, and I want it at 50% transparency. And the software is going to give you a preview as to what it can get. And it's going to be one challenge that you really don't have to think about. Now, I haven't talked about it yet, but this is probably a good slide to introduce the circular build tray. This is something that is so different about this machine. If you're familiar with 3D printing or 3D CAD in general, typically we think in X, Y, and Z, linear space. And when we talk about the dimensions of the build tray, we think in length and width and height. But with the J55, that doesn't apply because the build tray is actually round. It's a donut, really. It's a donut. I'm going to talk a little bit more about the dimensions here, but I wanted to show a preview of GrabCAD Print where we have some models laid out here in the build tray. I did mention that there's 5 core materials that you would load up on the machine. In reality, there's 6. One is a support material. That support material is there to allow you to build unlimitedly complex geometry. Overhangs, undercuts, that sort of thing. That support material is washed away with an electric pressure washer. The 5 core materials, you have some flexibility in what you might load up. So in a scenario like this, where we have some wood grain, we have some carbon fiber, and we want a very shiny finish on this, I might choose a scheme like this, where I have cyan, yellow, and magenta, and white. So really I have 4 colors and then clear. Now, if you're a designer and you're skeptical, like most of you probably are, you're probably wondering, how are you printing that black without a black material? You can't do black without black material. And technically, you're probably right. But in practice, Stratasys engineers have figured out how to do a very, very dark black without black loaded. I'm skeptical. I'm coming from experience in photography where we're really concerned about color, and I didn't think that it was possible. But I was handed 2 printed parts, and I was asked, "Tell me which one has black in it, and which one is a simulated black." And I took a guess. I was wrong, actually. In fact, the simulated black was actually a little bit deeper and darker. Less color or less tone to the black. So I was surprised. I'm going to show you guys this part here printed, and I would love for you guys to take a look at it and see, you can create some amazing colors. Now, with the wood grain, we're able to simulate a brown pretty well with this cyan, yellow, and magenta. And then that polish comes from a very, very thin layer of clear that's then polished. Note that we built 23 of these things in under half a day. And that speaks to the speed of this system, which we'll go into here in a bit. Quick reminder, this is the intended environment for the J55. This gives you a little bit of a sense of the size of the system. The overall footprint is not much larger than the build size. They did a great job of fitting a large build size into a small machine. And they were able to do that because of the kinematic system or the mechanical system of the printer. So we have that circular print tray. That tray spins, okay? So it spins. The print head, while it's printing, is completely static. So we're used to seeing video of a rectilinear build tray with the print head sweeping across it and then coming back, sweeping across and coming back. Well, you're only printing 50% of the time, 50% of the movements in that scenario. You're printing in one way and you're hitting it with the UV in the other way. With this system, the print head stays stationary and the table moves underneath it. And the timing is such that as it makes a revolution, the print head moves just a little bit, and then it makes a revolution, and then it moves just a little bit. And there's a lot of benefits to that. But in reality, you're moving less components, which means that your accuracy is going to improve and maintenance is going to go down. This does have a touch panel, just like the F-Series machines and the newest Fortis machines and the newest J machines. Great user interface. A lot of work has gone into making the user interface very simple. It allows you to operate the machine without any standalone computer or anything like that. The UV lamp has been replaced. Prior systems used a mercury lamp that had a more limited lifespan. This now uses a UV lamp that is more energy efficient and has a much longer expected lifetime. We have 12 material bays in this cabinet. 12. So we have 5 model materials, 1 support material, and each of those have up to 2 cartridges. So the total of 12 bays. And the idea is that as as a cartridge is depleted, and they're totally redesigned new cartridges as well, but as a cartridge is depleted and emptied out, the system would automatically transfer over to the next cartridge. And so that allows you to print overnight and over the weekend without worrying about running out of material. And then lastly here, you see a little add-on there. It's the Pro Aero air extractor. If you've been into one of our labs that was running a PolyJet machine, you may have noticed there was always sort of this very faint crayon smell. I think it smells like crayons. Very faint, not dangerous. But if it was in the same room as you and you were working day in, day out, I think it would become distracting. That was fine for a lab scenario, but on a system that's intended to exist in your office next to you, they do have a filtered air system that is completely silent and just captures any of those odors and keeps it safe as well for you to work next to. So that rotating tray, we're trying to wrap our heads around how we're going to talk about this, because in the past, it was really easy to communicate the size of parts that can fit on your system. You have XYZ, you can fit a part that's up to XYZ. Now this gets a little tricky because of the donut shape and also this transfer zone. So you have the rotating tray, like I mentioned, and if you look at the image here, you'll see that we have what I've labeled as an active tray and what's labeled as the transfer zone. That transfer zone is dynamic. It changes size depending on the parts that you place on the platen. And it's something that I'm looking forward to playing around with. In most cases, you have access to about 70% or so of the build tray. Now, also keep in mind that you have a much bigger build tray than even machines that are physically much bigger and more expensive. Because of the donut shape, you have more total volume, significantly more total volume than a comparably sized rectilinear tray. But anyway, we don't put parts in that transfer zone because that's the zone where the head's going to move. It's going to have to transition over. The lamp sits separate and is stationary. You also see 3 swaths or paths, rings, I guess, on the build tray. And those correspond to the width of the print head. So if you're talking about speed of your print, it's a function of the height of your model, how many layers. By the way, our layers on this are 7/10,000ths of an inch tall, 7/10,000ths of an inch, 0.0007 inches. So it's a function of Z height. And then also the number of paths that your parts lie in. If they all fit within that inner ring, it's going to print very quickly. Very quickly. If they reach out into the second path, then your print time is going to go up. And if they reach out all the way into the third path, your print time is going to go up a little bit more as well. Now, here's what I'm talking about. This gives you a good idea of how you might handle parts. In reality, you can fit a pretty big part on this build tray, something like 17 inches long. But it's going to have to be skinny. The shape is going to have to be right. We're not really trying to market this machine as one that will replace something like a J826 or a 835 or an 850. Those all have bigger rectangular build trays, so you can be more confident that they're going to be able to handle a wide variety of large parts. The J55 is geared more towards palm-sized parts, fist-sized parts, and many of them at a time, different iterations all at the same time. So while there are circumstances where you can get a part that's quite large, the anticipation is that you're going to deal with more of like your fist-sized parts. So speaking of parts, I'm going to show you guys some parts before we wrap this up here, and then we'll also take some questions. I'm going to switch over to the camera feed. And all right, so let's put the zoom on here. I'm going to show you some parts out of the design kit. First one I'm going to show you is a very simple part. This is straight off the machine, no post-processing. This would be Vero black with a touch of cyan. You can see the text in there. And on the back side, we have this really intricate design that is made possible by the support material. And you have some very thin-walled parts, very thin-walled features there. So even though you're blasting off that support material, you can still create very delicate parts and features. Let's jump over to something like this. So when we're talking about being creative, being inspired, this is a great example part where we have some beautiful colors, beautiful surface finish, intricate details. Trying to create a prototype of this or a molded component, very labor intensive, very costly. But with the J55 workflow, it really just comes down to what can you model? I like this example here. This reminds us of all of our mom's china. This is right off the machine. This is a Vero white part. It's got a matte finish. Okay, so it has no glare, if you guys can see that. And if we kind of zoom in on these details, very fine details, you can trust that not a lot is being lost in communication here. Let's look at some of the more interesting parts. How about this black polish part? Look at that. You guys can see my window in the reflection there. Look, you can see all sorts of details in my office there. So this is just Vero black. Okay. The inside is Vero pure white. That's how these parts are printed. The inside would be white. This has been sanded and buffed by hand. Very high gloss, single material part. If you're trying to simulate high polish, injection molded parts, this would be a great option for you. Something along the similar lines is here's the part that I promised I'd show you guys. We've got some simulated carbon fiber and some simulated wood grain. This is all 3D printed. Now, the design process for this may be as simple as applying the appearances in SolidWorks and exporting a 3MF file, or using something like SolidWorks Visualize or Keyshot or some other rendering tool and exporting an OBJ file or a VRML file. Another thing to note here is that leather. You guys see that leather texture? I think if you handed this to anybody on the street and you said it was 3D printed, it would blow their mind. And the same thing goes for any sort of prospective buyer or stakeholder that you might be trying to sell to. Here's another example. This would be an excellent prototype. Let's get this in focus here. Look at this. So you actually have this simulated speaker texture. Simulated light pipe. And as I mentioned, this color is totally under your control. Pantone validated colors. You have a lot of colors to work with. Almost 500,000 colors. This side is gloss. You guys can see that. That's sort of the natural gloss finish off the printer. And this side is matte. This is the natural matte finish. You get matte or gloss depending on whether or not support material is in contact with surface at the time of printing. So this was printed this face up with no support material on the top, and support material on the underside leaves that matte finish. One last part here. Look at this. We've had clear in the past, but nothing this clear. Look at that. I mean, I can... This is a much better clear than we've ever had access to. So all of these parts can be created on the J55 and or the other J series machines. The only difference is the amount of different colors or base materials you're going to be able to print at once. The J55 currently doesn't have the Agilis materials, the rubber-like materials, or the ultra clear material, but things change. Things change. And that's it. So I want to thank you guys for joining me today. Watch out for the next video that we release, because it's going to be a video of us playing with our J55 here in person. It's ready to be uncrated as soon as I finish this webinar here. Super excited about it and looking forward to sharing that with you guys. Thank you for joining. Catch you next time.